Okay, now I'm going to talk about when we take these numbers and these formats and transfer it into or out of the core. We talked about coming in, but going out of the core, this is where the saturators come in because you got to know if the number is too big. So here's what has to go out is a 1.23 number. This is a it's equal to 24 bits, right? So it's a 24-bit number. That's what the serial port's going to output. Now, I do want to say though, we can set the Sigma 300 cores to be 32 bits out and in, but that's a subject for a different video. Um, but for the old, especially the old Sigma 100 and 200 cores, it takes the 28 bits and it goes to a 24-bit number, and that's it. Um, so um, the dot 23. So let's talk about the Sigma. Let's do the 100 200s first, which is a 28-bit number. So we have uh, a 5.23 number that we need to transmit out of the core. So obviously let me change colors here. The 23 part is going to go straight out as the dot 23. Piece of cake. It's this part. We only have one digit now, and we have five here. So we have 5 bits. One, two, three, four, 5 bits, and then the dot portion that we have to bring down to a 1 bit. Now, keep in mind that this is the sign bit. So sign. This basically, we're going to shift the sign bit over. Exactly. So we're going to lose these 4 digits and we're going to move the sign bit over. Or, we're going the other way around, you're calling sign extend. We're sign unextending. We're going to saturate here. So what we have to know is, was there anything significant in here? Is this number bigger than 24 bits? If it's bigger than 24 bits, then there's going to be a 1 in here somewhere. Any one of these. If there's a 1 in this position or a 1 in that position, there's a 1 in any of these positions, it's going to mean that you can't just bring the sign bit back. The number was too big. So you have to check, and I've done programs to do this where I've had the bit bang stuff. If any of these equals a 1, any one of them, then the data is saturated. What you're gonna get, no matter what this, I don't care what's in this dot 23 part, what you're going to see coming out of the serial port is going to be a 0 for the front. I'll do it in hex. It's going to be 7 F F F F F. I don't care what's on this dot 23. This is what you're going to see, which means it's a maximum. It's clipped. This is a maximum positive number in 24 bits. If you remember the hex, this is why you got to get good at the hex translations. A 7 is a 0, 1, 1, 1. So the sign bit is a 0, meaning it's a positive number. Then 3 ones, and of course F's are 4 ones, so all the rest of these are ones. So it's a 0 and then 23 ones. That's what you're going to see. And it'll catch you. It's caught me before where I'm trying to put a value in and I'm looking out of the serial port and I'm getting 7FFF. Why am I getting? I'm not putting 7FFF in. Well, it's because I had a 1 in one of these positions. And so it's clipped. It's too big. So that's the positive side. On the negative side, okay, um, well, I could have stuck with it. On the negative side, the sign bit's going to be a 1. And if it's, the rest will be 1s. Okay, 1, 2, 3, 4. So we got 4 1s, which means this means it's a negative number that is not too big because you can have zeros in here. Because because this is going to be just the opposite of the positive case. That, because if the smallest, if we go from 0 in two's complement to a -1, we just subtract one bit, we end up with 1, 1, 1, 1, 1, 1, all ones. That's a very small negative number. So that's why all these being ones is fine. It's absolutely fine. Um, where you have a problem is if one of these, I'm going to spread these out a little here, is a 0. I don't care which one. If we have 1, 0 on here, the negative number is too big and it'll clip. Pretty straightforward. So if any one of these is a now we're not going to check for a 1, we're going to check for a 0. If any of one of those is 0, then we're going to output to the 24-bit serial port a clipped signal, which is going to be 800000. That's a max negative 24-bit number. Now, remember quickly, you got to get quick with this hex conversion. I keep smiling because it's something I learned through the years. Uh, an 8 is a 1000. And then obviously the rest of zeros are all zeros. So you have a 1 saying it's a negative number, and then all the rest are zeros, which is a maximum negative number. And so that's the clipped. So on the positive side, it'll be 7 FFFF, F, there's 6 digits. On the negative side, it's going to be 80000. That's going to be the max negative. And so that's that's the saturators. That's what happens when you go, clippers, saturators, whatever we're going to call them, when we're going out the serial port if the numbers are too big. Now, in the Sigma 300s and 350s, um, we're going to a 1.23 number again, but this time we're starting with we're doing it at, well, we're doing 8.24 number is the format we have. All right. So we're going to take the 23 bits and transfer those up to the 1.23. We're going to take bit, well, I want to say bit 24. We're going to bit 0 and we're going to throw it away into the bit bucket. Here's the bit bucket, into the bit bucket. Um, and truncate that. It's gone. So the LSB will just get truncated, and the most significant 23 bits of the fractional part gets transferred up to the 24-bit number. And then remember we have 8.24. The first one being the sign. Let me do the positive case again. So it'll be 0, 2, 3, 4, 5, 6, 7, 8. So we have 8 digits in the for the whole number, and the first one being the sign, and so we have 7 bits here, 1, 2, 3, 4, 5, 6, 7, that are the whole number portion. And so going out, if any of these is a 1, any one of them is a 1, if the number's too big, and we'll get that 7 FFFFF again, the max positive. And in the negative case, this is going to be, the sign bit will be a 1. Then we'll have 1, 2, 3, 4, 5, 6, 7 ones, right? And then again, if any of these is a 0, any one of those 7 is a 0, then it's saturated and we'll get an 8, 0, 0, 0, 0, 0 out as a saturated number, maximum negative number. Um, so that's how that works. And I have some programs. Eventually, I'll probably get up here where I'm doing some compression of data, and I'm having to reestablish the sign bits the proper way. So you had to be really pay real close attention to this in that case. The hardware takes care of it for the most part for us. Coming back and forth from the serial port, the hardware just does it. We don't have to deal with it in software. It will automatically truncate this and saturate it, and we're good. So that's awesome. Yeah, I think that's everything I need to talk about for this. Thank you.